Welcome back to this lesson. This lesson is on multimeter, and today this lesson, we're gonna talk a little bit about the multimeter and some of the features on multimeter and some of the things that you guys may want to look out for when you guys buy one, or maybe just to get a little bit of understanding on how to use it. And then I'll show you guys kind of how I use it and basically the ones that I use. But I sent out a survey maybe 2 months ago, trying to get some feedback on the people that was on my list on basically what they would like to be included in the training program. And I was really shocked when the number one thing was multimeter. How the amount of people that wanted to learn about multimeter. To me, right, is one of those things where I know it, and I'm thinking like, this is so easy. Why are you requesting to learn about multimeter? I mean, it's pretty easy, pretty much self-explanatory, and I didn't understand that. But I try to take myself out of my own shoes and look through the different lenses of other people's eyes and try to understand where they're coming from. So if I look back in the days when I first started, I wouldn't really know how to use a multimeter either. So today we're going to talk about that, and I'm going to show you guys some of the features. My preference has always been Fluke. I've used other meters before, and I've just never really liked it. And Fluke has always been good to me, so my whole shop is basically full of Fluke meters and basically anything that's related to Fluke. So basically what I'm going to talk about is Fluke. What I need you guys to understand as far as multimeter goes is that even though there's some very cheap ones and there's some expensive one, get yourself a decent one. I've heard other people say, like, about motorcycle, because I used to have a motorcycle, and they would say however much you think your head is worth, that's how much you'll pay for your helmet. And if you think your head is worth $10, then go buy a $10 helmet. But if you think your head is worth $1,000, then go buy a $1,000 motorcycle helmet. And that's kind of how I look at Fluke. And if you buy the real cheap one, they won't give you accurate readings, and they won't fit into certain categories depending on what you guys are working on. Like, for example, there's like different categories, and these categories would be rated for different voltages, but it's really ideal for a certain environment, and I'll go over that in a bit. But if you want to go cheap, then don't expect good results. But if you want good results and you want good protection, then go with a more expensive multimeter. There are so many out there as far as like different models. It's basically what you do, and then what kind of meter would meet that need. So if you're only doing like a computer repair, and you're working with like low voltage, like 110 single phase, then buy a cheap one. Those are normally rated at category 3 or 2. I think, yeah, category 2, where it's single phase 110 and low voltage DC from like 5 to 12 and 24 volts DC. And that would be the type that you would go for. But if you work in a industrial place where you have 3-phase coming in, and maybe even like high voltage, I mean, not high voltage, but higher voltage, the 3-phase up to like 580, and then you'll need like a category 4 or 3, right? 600 to 1,000 volts. And so just what I'm trying to say is that identify what will work best for you. Don't just go out there and spend a lot of money just to have a real nice meter and you never use all the features. But don't go really cheap to where you're going to end up hurting yourself and blowing up the meter. And so don't go cheap but make sure that you pick one that's a little bit over what you're doing, so that you have that protection there, and that one will perform well for whatever you're in. Because I don't know what all industries you guys are in. I know some are in the medical, some are in industrial, some are computer. So it really is, you guys gotta have to determine that, and you go to like the manufacturer's website and look up at their different models and figure out which one will work best for you guys. So with that being said, let's move on to look at some of these Fluke meters, and I'll show you guys how they work and how we use them. So let me flip this around. All right, these are the 3 Fluke that we mainly use in here. This is a Fluke 77, and then here's a Fluke 117 newer model, and this is the newest model. Not the newest, but I've had it for about 2 years now. But this is the Fluke 289, way more expensive. I think this one, if I remember correctly, is about $200. So I think around 170. This one, I bought this one, was like right at around 1,000, and I don't remember how much this one is. I use this one the most. This is what I keep on my workbench. And then these right here, my techs use these. So don't want to get too much into these. They all have different features. They're all suited for certain things, but they also do a lot of the same things also. And like I said, all these are used here in the field. I mean, on the workbench. I use this one in the field a lot. This is where I go and take it out on the field. There's a lot of things you could do with this, but we'll just mainly focus on the main features, because there's a lot of you guys out there that would use different type of meters, not necessarily Fluke. There's so many other brands out there, from well-known brands to really cheap brands, and so they all have basically the same features, just maybe a little bit different on how you use it. Because like some of these, like for example, these settings here, right, they are automatic, so they automatically go, and you can see I use it so much that battery's out. But they are automatic, and there's some that you have to adjust up to, like certain voltage. You have to increase it by a certain increment. But these are all just the same. They automatically adjust. All right, so like I said, I really love Fluke, and they have their own different purposes, but we're gonna focus. I'm gonna go through and we're gonna talk about all the features on here, and then I'll really focus on the ones that really is important as far as being a tech. Okay, so if we look at this one over here, right, I'm gonna turn it into here. If you guys can see, let me scoot this out just a little bit. If you guys can see, this auto V, the auto V stands for auto voltage, right? Obviously the V is a voltage, and what it does is, even if it's on AC or DC, without having to change it to AC or to DC, when you leave it on this mode right here, it automatically knows, and it will give you the reading. So let me prove that. All right, I'm gonna put AC on there, and then you see it's 41 volts, right? And as you guys can see right here, it says AC. See? And then I'm going to switch over to DC, and you can see it's 12.3 volts. What? DC. So that's a cool thing about this feature on this model here, and this one of course has it too. I mean, this one don't have it. It does have the low impedance, but yeah, it does. Sorry, I don't really use it that much, but that's the cool thing about this one is the auto V. It automatically adjusts, and it could tell you if it's AC or DC, and it automatically throws it out and gives it to you. Another cool thing about this is the low Z, right? Z is impedance. Impedance mainly is for AC voltage. And this one right here with the low impedance, it gives you a very accurate reading. And they call that, they call a voltage that is like maybe like your wires or something that is creating a charge, which is going to give you some voltage reading. It's going to, what this does is it's going to eliminate any kind of ghost reading. So it's going to give you like a very accurate reading. So I don't know if I could produce it here, but normally if you put it in through your outlet, you could read it. So for example, I'm going to set it to that. I'm going to try to see if it works because I haven't tried it. Yeah, 45.5. Yeah, 45. So my power supply is working like it should. So I'm not going to read that, but that's basically what it's for. So it's to read, to eliminate any kind of ghost reading, any kind of voltage that's present there with a charge that's not supposed to be there, and it just give you a good reading. Obviously the off, and then this right here, your sine wave. You see your sine wave is for your voltage. All meters have that, and like I said, these right here automatically adjust to whatever voltage is reading, and it will display that as you guys saw. On top is your duty cycle. So if you not duty cycle or frequency, if you guys want to read some kind of frequency, then you guys could put it on there. And what I'm gonna do is I'm gonna set this up, and I'm gonna put a frequency reading for you guys to kind of test it. Okay, I got my signal generator ready, and I'm gonna put what I did was I left it on here. Right, in order for me to get the hertz, I have to press this button, which I did already. But if I press that button, it's letting me know that it's going to be reading frequency. So what I'm going to do is I'm going to put my clip on here that's coming from my frequency generator or signal generator, and then I'm going to put it here. As you can see, I'm right at 10 kHz, and I'm going to adjust my frequency. You can see it go down. So I'm going to add an increment of 1,000, and if I'm going to go by an increment of 1, let's see how accurate it is. So this thing's pretty accurate. My frequency or signal generator is right at the 6.05 hertz. So no kHz. I mean, I'm trying to look at it differently, but you can see that's what your frequency is for. I don't really recommend measuring this way. I found that it's not 100% accurate. So it's a feature there. I may be wrong in it, but I don't really use it because I have other equipments in here that would measure frequency a whole lot better than that meter. But whenever I'm out in the field, then I would definitely use it. Or if I don't have my oscilloscope, then I would definitely use it. All right, so let's move on to the next feature, DC voltage. Basically, that's what it means. It's just DC voltage. This is millivolt. If you want to read low voltage in the millivolts, then you would switch it to that. I don't know why it's kind of jumpy here. Maybe it's picking up some noise from somewhere because it's such a low voltage that it's probably picking up other things. So here is the ohms, measuring resistance or any kind of resistor. We use that quite often, and this is the one we use quite often too when we're tracing things on a circuit board. It's basically a continuity test. So if I touch here with 0 ohms, it's gonna beep. As you can see, for that signal here, it's giving a sound. And then you can see over here the resistance, which is 0 ohms. I think it goes up to like maybe 50 ohms before it quits beating or something, somewhere around there. But this is what we use it for. And then here is your diode reading, right? So we'll get more into the diode. I'll show you guys in a bit, but you set that to the diode, and then you're on your way to testing diodes. A lot of people use it just to see if there's any short, and they will use that too. So if there's a dead short, it'll beep too. And basically what is doing is it has like a 9-volt battery in the back here. Like if I do this and oh, this thing's missing a screw. So I guess one of my tech lost it. But you have a 9-volt battery in here, and basically it just goes in here, and then you would just screw it in. I might have to find out why they're not taking care of my equipments. So basically it's giving out some kind of voltage, right? And it's going to put it across the diode, and it's going to come back and give you a reading on the voltage drop on the diode. So if I set this on volts, and if I put my red here and my black here, my common, you see it's giving out 2.486 volts. So that's when you put it on the diode setting. So that's kind of how you test the diode. So just remember that you're putting a voltage out, okay? The next one is your capacitor. Again, you have that you have that option, but I don't really use it because we have other meters in here or other testing equipment in here that does it better. But if you guys don't, it's also a good tool. So here's a capacitor, and if you guys look at it, it's 1035. So if I want to test that, I'll just go back and press this button. Forgot to mention this too. This is just basically to turn on the display light like that. All right, so this thing automatically senses the range. So you see here there's a negative, and then so if the negative is going to go there, I'm going to touch it there. Let's do like that. Oh. Bear with me here. And then I'm going to touch it here. And I'm getting 992, 978. And as you guys can see, is 1000. It just checks for your microfarad. This thing doesn't check for any leakage or anything on the caps. So that's that. And this right here is your amperage. So if I want to test my amperage or my amps, then I would have to take this out. As you can see, this is only for your capacitance, your diode, your continuity, your resistance, and your voltage. And this over here is your amps. So this is rated at a 10 amp. There's a 10 amp fuse in there. So don't go over 10 amps. If I put it in here, then I'm ready to test my circuit, or test how much amps is being pulled from my circuit. Here you could test the frequency too on your circuit. So another good feature. And then this is more for AC, and then this is for AC. And this volt alert, basically it lets you know if there's any voltage by letting you know. Right, so if there's like a voltage, it will let you know. So it's good to. So right here I'm putting it close to my power supply, and it's letting me know there's voltage around. I'm going to take it away. All right, so I took it away, and now is no longer beeping. One thing I want to mention too is very important that you guys get the one that says on true RMS. Basically, this true RMS is to give, what RMS stands for is root mean square, is just a calculation to give you the most accurate reading for any of your like sine waves, AC voltage, duty cycles, square wave. It's going to give you the average, so it's really going to be accurate on that part of it. So if you guys don't remember anything else, just remember that you want to get one with a true RMS meter. So this is it for this meter, and this meter for a typical electronic tech, this meter will do. One other thing you guys want to do too is you guys want to make sure that you guys have the right like probes. Okay, so see these right here, these are rated for 10 amps. I don't know if you guys can see it. See how it's rated for 10 amps, and it's category 2 at 1,000 volts. So you want to make sure you want to make sure that you have the right probes. You don't want to use a probe that can only handle a few amps, and you're testing like a 8 amp. So be careful with that. Make sure you have the right one. Here's one that we use in house, which we really like because it has a really sharp. It's good for like low voltage and troubleshooting. Don't use high voltage, but this is really good when you have to really get it on the board or a small surface mount. And these are fairly cheap. I think we got these for maybe around $8, and they're fairly cheap, but they're good for low voltage troubleshooting. And we use these a lot. So Fluke 117 has all the necessary feature that you would want on there. Let's look at this one real quick. The Fluke 77. Let's take the 117 out. So the Fluke 77 is one, like I said, is on my workbench that I use a lot. And it doesn't have a lot of features. It just has the off, AC, DC voltage, millivolts, resistance, diode, and continuity, and your amp meter, so AC and DC. It has the same feature as this one right here, and this one right here, I forgot to mention too, is a category 3, is up to 600 volts only. So don't go testing anything with 1,000 volts because you'll blow this meter up. This one right here is DC, 1,000 volts, and then you can see there 750 for AC, and these are my amperage. This is if I want to test 300 milliamp or 10 amp. Right, then that's basically I got to make sure I put it on the right one. What I normally do is I normally just put it on the 10 amp and it reads fine. And this right here is just an auto range if you want it to. If you can't really find a good signal, just hit the 1 second, and then it'll try to find whatever voltage it is. Again, typical meter has all the function that you need. So let's put this to the side, and then let's look at this bad boy. I really love this meter. If I turn it on, I won't go through all the features because it's going to take too long. I'm already too long in this video already, but it has everything from what we just talked about, like the low impedance, the automatic voltage, the AC, millivolt AC, DC voltage, millivolt DC. It even have a for reading temperature. I lost the word for it, so you guys know what I'm talking about. And then you guys right here, you have the option of resistance or option of the continuity, and there's also NS. I'm not quite sure what that is. Never used it, so forgive me. I don't know what that is. And then on this section here, you have your diode and your capacitors, and then you have your amps, right? Milliamps, amps, microamp, and this is just a low resistance reading. So cool feature, right? As you can see, this plug right here goes for all these. And then this is my common. This is 400 milliamp, and this is up to 10 amp. Here is the light, right? I need to come on, and this info right here is really good, because if you're like me, you don't know everything. So if I hit info, it's gonna tell me. Let's see if I could zoom in on here. You see how it says there? And then I could see that I could scroll down or up, but it tells me what it is. Like, so it says continuity detects, and then it tells me intermittent opens short lasting a little bit as 1 millisecond. These brief contact causes the meter to emit blah blah, right? I could hit next for measuring resistance. I could go back. If I want more, I hit more. If I want to close it, I'll close it. But if I'm gonna find out what that NS is, let's find out what that is. So apparently my battery on here is low. I probably just need to take it out, and I'll show you guys. Since off, right? That's my off. Let me back this out. All right, I figured out how to look closely on it. There's a little. I don't know if you guys can see it there, but you can see those lock. See how that right there is? I couldn't tell from looking from where I'm at, and that basically unlocks it. And then I could just pull this out, and you can see my fuses in here, which is very cool. If I ever blow it, I could replace it. And then here is my batteries. So I might as well gonna replace my battery now. So hold on tight. Okay, I put my battery back in, and everything should be working now. Like, my lights is coming on good. But got it all in, and just to kind of go over these are just features of this thing. There's I don't remember if I mentioned it a while ago, but yeah, I could go in here and hit this info, and it'll tell me all what it means. Again, I don't know what that NS means. I'll have to look it up. But if I need to, let me exit out of this. If I need to, like, record, which is the good feature about this right here, is I could go in, I could set it up. I could set up all the things here, from like reset to meter information, instrument. Let's do meter info. It'll tell me all the information about it. And so if I want to close out, I could do that. I could go back and hit the menu and just kind of, I think I hit the wrong one. Let's exit back, close, hit menu. Just gives me different options. Here is where I could save. Like, if I wanted to record my voltage, I could hit save, and then I could go in here and I could save. All right, so it'll start recording. I can name it, but if I want to save it, I could do that. I could view whatever I've saved. I could even delete. If I want to record, I could hit record, and then I could set my duration. Right now it's set to 11 minutes, and I could do that. I have 97% memory left, but I don't want to do that, so let's not do that. If I want to hit setup, right, I could I could set like my threshold, but I think I might have done that a while ago. But yeah, there's just a lot of things I could mess with in here. Like display, we could do that. We could do set our time of day, even format. So there's a lot of things this little thing could do, and that's why I really love it. But I use this as I do any other meter. So that's why I was saying that just figure out what you guys need, and then go out there and buy what you guys need to do your job. So this is a little bit about the multimeter. Has a lot of function for it, and then I'm gonna get a board and kind of show you guys a little bit about it. So I'm gonna go through and kind of go through this really quick, because I know I've spent a lot of time on this video already. But if I have a board like this is a switch mode power supply board for a servo drive. But basically what I would do first is I would put it on the diode setting, and in this case right here, I'll have to go through here and set it to the diode setting. But basically that's what I would do. I would use that as my continuity. So I'm going to check, here's a fuse here, I'm going to check this fuse, and then I'm going to check a diode here, right? It's so quick to just go through and check all these diodes. There's like 2 diodes in here, if you guys can see it. Just quickly check these diodes, and just look at all these diodes. I could go through and just check, just make sure that I'm getting voltage drop. So what I do is I'll just go through and check all these diodes out, and you can see there it has some kind of, it's probably across a capacitor. That's why you can see it charging. So you could do that. If I want to test ohms, I could come in here. I could check these resistors out. And this is like a 10 ohm or 11 ohm. This is probably like a tolerance on there, and I could go through and just check these diodes out. Most of the times, these little small quarter watt resistors don't have problems anyways. A lot of times, your caps and your main power. These are MOSFETs that's in here, right? I could flip it around, and it'll be here. I'll put it on the diode setting, and then I'll just make sure that they're not shorted. Got to change that back to diode. My main thing is I'm just checking to see if they're shorted. So I could go and do that. If I wanted to, check my capacitor, it's not good to be checking capacitors in circuit with these meter. Not recommended. Like this one right here, this capacitor here. You see how this is a 100 microfarad at 400 volts. This one's checking fine, but this is not ideal, okay? These are not made to test in circuit. This is a, it says 100 microfarad for this one, and these are 470. So I'm going to check these guys out and see if I'm actually getting any kind of reading. 4 microfarad. $177 microfarad. So not recommended. We normally just replace this cap. So the main thing we use these for is to check voltages, do a diode check. If we need to do continuity, we could do continuity, and if I need to trace where this right here goes, I could check for continuity. So it goes here. And it probably goes somewhere else too. I don't know where. But that's mainly what we do with it. If I'm going to power it up, which I'll go ahead and power it up. Alright, so board is powered up. If I want to measure DC voltage, I set to DC. I want to find my common, which I know is over here because of this bus cap is negative here, and then that would be my common. I also know that I think this pin here is common, and if I was to measure voltage, I get 15. I should get negative 15. And then about 23 volts. So if that's my common, I want to check my voltages. I'm getting 15 there, and just going around and just check my voltages. 0, 15, 15, 15, 15. That's just going to be 0 because that's my ground. 15. If I want to check over here, negative 13, 0. So if I want to do that, I could check those out. AC is the same thing, but those are basically the only thing that we would do as far as checking out or troubleshooting, knowing our voltages, checking if it's there, and then mainly using the diode and resistance and continuity to check it. So I think that's pretty much it for the multimeter. It's pretty straightforward. It has a lot of features, but doesn't mean that you're going to use all of it. And we do this every day, and we don't use all of the features, but we just have the capabilities to do it. So that's it for this one, and I'll see you guys on the next one.